Welcome to my YouTube channel. In this video, I am going to explain the spontaneity of redox reactions. You may know that as a fact, for any reaction to be spontaneous, the Gibbs free energy of the reaction should be a negative value. We denote it as delta G naught. The Gibbs free energy for any reaction to be spontaneous, delta G naught should be a negative value. So how do we find delta G naught for a cell is equal to minus NF E naught cell. N is the number of electrons transferred in the balance equation and the F is Faraday's constant and E naught cell is standard potential of the cell. So then let's look at how do we find the E naught cell or the standard potential of the cell is equal to E naught cathode minus E naught anode. E naught cathode is the standard electrode potential of the cathode. E naught anode is standard electrode potential of anode. For a reaction to be spontaneous, E naught cell should be a positive value. Why is that? N and F are positive. N is the number of electrons transferred in the balance equation. So there is a positive. Faraday's constant also a positive value. So that N is a positive value, F is positive value. So E naught cell is also going to have a positive value. Now it's multiplied by a negative sign so that this whole side is negative. Therefore, delta G naught cell is a negative value. Therefore, E naught cell should be a positive value. Let's see this example. Zinc copper electrochemical cell. Zinc electrode in the zinc 2 plus 1 molar solution and copper electrode, copper 2, 1 molar copper 2 plus solution. So the reduction potential is standard reduction potential for copper is 0.34 volt and the reduction potential for zinc is minus 0.76 volt. So as we discussed, the higher the reduction potential, the electrode is going to reduce. In this case, copper has the higher reduction potential. Therefore, copper electrode is going to reduce. And zinc electrode is going to oxidize. And the electrode where the reduction is happening, we call it as cathode. And the electrode where the oxidation is happening we call as anode. Now let's look at this example. Check the spontaneity of the reaction between tin and copper 2 plus. Determine what is going to oxidize and what is going to reduce. Here the standard reduction potential for tin is minus 0.14 volt and the reduction potential for copper 2 plus 0.14 volt. So therefore the highest reduction potential is for copper. Therefore copper 2 plus reduces. When the reduction potential is higher, it is going to reduce. Therefore in this case copper 2 plus is going to reduce. And tin is going to oxidize. Determine the anode and cathode. Electrode of oxidation half reaction happens, we call as anode. And electrode of reduction half reaction happens, we call as cathode. So in this case, cathode is copper 2 plus copper electrode and the anode is tin electrode. Calculate E naught cell. E naught cell equal to E naught cathode minus E naught anode. In this case, cathode is the copper electrode. Therefore, E naught cathode is 0.15 volt minus anode is minus 0.14 volt. Therefore, the inert cell is 0.29 volt. In this one, cathode is copper. Therefore, inert cathode is 0.34 volt minus inert anode is minus 0.76 volt. So the inert cell is therefore 1.1 volt. Inert cell is a positive value, therefore this reaction is spontaneous reaction. Here also inert cell have a positive value, therefore this reaction also a spontaneous reaction. I hope this video is helpful. Thanks for watching.